This is a review of the target 7b, identifying the features of a graph of a rational function by simply looking at the equation's features. Starting off looking at a rational expression equal to f of x, this rational function, I need to have it in factored form. That way I can identify the equation's features and match them up to the graphed features. This table, or something very similar to it, it's been shrunk down. This table is inside your resources section of Module 7. At the bottom, look for it, please. So when we turn this into factored form, notice that we can factor a 2 from both those terms. We can factor an x from both those terms. Also, this is the difference of 2 squares. You should know how to factor that. Factoring yields this equation. Factor out 2x, you're left with an x plus 4 as another factor. Now you have 2 factors from the difference of 2 squares. Now we're going to start identifying the graph features, the holes, the x-intercepts, the vertical asymptotes, the y-intercept, and the horizontal asymptotes by using this table as a reference. So, are there any holes in the graph? Well, we're looking for common factors in both the numerator and the denominator, such that the values that end up in the numerator and denominator is the values of x that will cause both the numerator and the denominator to be 0. And that's another way of looking at it. Well, I don't have any common factors in both numerator and denominator, so I don't have any holes. Let's look at x-intercepts. The numerator, just the numerator, is 0 at these values of x. What values of x would make this whole thing equal to 0? Well, because there are no holes, we don't have to worry about a 0 being both numerator and denominator. The factors are different. So 0 for x would give us 2 times 0 times 4, which is 0. Inputting a negative 4 for x would give us 0 times negative 4 times 2, which is also 0. So my values of x that give me a value of 0 overall are going to be 0 and negative 4. Those are my x-intercepts. My vertical asymptote, denominator but not the numerator, is 0 at these values of x. So where in the denominator are the values going to be 0? Well, if x is 2, this becomes 0. If x is negative 2, this factor becomes 0. So negative 2 and 2 are my vertical asymptotes. And the equation for a vertical line is x equals some value. Those are the equations for my vertical asymptotes. The y-intercept. If I input a 0 for x, my output is going to be my y-intercept. Inputting is 0, I get 2 times 0 times 4 is 0, all over negative 2 times 2, but that doesn't really matter because the numerator is 0. My y-intercept is 0, because if I input a 0 for x, I have an output of 0. And finally, horizontal asymptotes. What is the long-run behavior of y? Well, we can make a table of values. I'm looking at the long-run value of y here. So if I input values of negative 10,000 and 10,000 into y separately, negative 10,000 times 2 times negative 10,000 plus 4, which is very close to negative 10,000. I get a very large number that's positive. times 2. Notice in the denominator, a negative 10,000, subtract another 2 is just a little bit more than this. Negative 10,000, adding 2 is a little bit on the other side of this. The product of both is going to be positive. I have a very large positive value here, a near equivalent very large positive value here, and the only difference between the numerator and the denominator here is going to be the fact that the numerator is nearly double what the denominator is. So your horizontal asymptote is going to be 2. Your long run value is 2. As we go to the extremes of both negative infinity and positive infinity direction, the graph is going to approach a line that is y equals 2. That's it. You should be able to identify the features of a graph without having to graph, just by pulling the features or understanding where the features come from the equation.